Hey everybody, it's once again time for the SMC Journal podcast, the show that's all about performance engineering and IT today. I'm Scott Moore, your host. Thank you for being with me. Today's show is about network performance. I never like to leave that out when we're talking about performance. We many times talk about the shifting left into code or shifting right into observability, but there's the network layer there as well. We need to also address that. Now, my friend Peter West has been on the show for the performance tour as well as this podcast where we've discussed in the past cellular routers, Starlink, 5G, and these technologies that primarily run on that network layer. This is a problem that everyone has that's trying to go mobile, work remote, that's trying to possibly bond multiple connections together and not traditional home network stuff. We're talking about things where you're trying to bond 5G, LTE, and then Starlink all together. That's really where the world is going these days. What if you're trying to work from your personal yacht and you're running around different locations and you've got to be able to get good signal wherever you go? I know a lot of people are having that problem. I'm not, but I'm sure you are. Anyway, Peter has put on a tech summit conference, and the first annual one happened in early November, the 7th through the 9th in Savannah, Georgia, and I was able to attend that. I wanted to share my experience with that and some interviews that I actually got during the conference. Before we get into that, let's talk about the sponsors that make the SMC Journal podcast possible. This episode is sponsored by Micro Focus and the LoadRunner Solutions family. That includes LoadRunner Professional, Enterprise, Cloud, and Developer. You know, performance matters. Did you know that LoadRunner Solutions have the largest community of practitioners in the world? Join that community at community.microfocus.com, scan the QR code, and check out the LoadRunner family page on performance engineering, as well as their YouTube playlist that we've got links for in the show notes on smcjournal.com as well as YouTube. This podcast is sponsored by Oracy Software. For over 20 years, Oracy, a DevSecOps innovator, has helped companies innovate, accelerate, and automate the entire software development lifecycle. Oracy AppSec and Oracy Cloud Solutions and Services offer full lifecycle support and integration to ensure scalability of transformative applications. Also, they're the makers of Oracy Labs, the train anyone, anywhere, anytime AWS cloud-native virtual e-learning platform. Oracy works with hundreds of global brands as customers and partners, including Fortune 500 companies across a variety of industries. Find out more at oracy.com. This podcast is sponsored by Folk Consulting. They offer high-quality consulting services around application performance management and operational monitoring of system performance. Ryan Folk and his staff of highly experienced consultants can handle any of your needs around application delivery management, analytics, application performance testing, monitoring, and digital management. Find out more at folkconsulting.com. So I'm going to share some pictures with you from the Peplink Tech Summit that I attended in Savannah, Georgia. This was a smaller conference, probably less than 50 people. This was the main stage, main floor. It was 3 days of solid training, presentation, information, and also interactivity and feedback from the attendees. And there was a representative from Peplink that was there. We had a full house, as you can see here, and the Peplink representative was listening to a lot of the feedback and feeding that back to the company. And my understanding is this is how a lot of the firmware updates happen within these Peplink routers to add new features. And some of the features that are happening with these devices are pretty incredible. We're now talking about putting Docker containers and even full VMs on router machines. Like, we're not talking about full-blown computers, just the routers themselves. And that was actually demonstrated at this conference. And many of the people who attended here, there's actually somebody who flew from Australia to be there. So this was a unique event where some of the attendees said, you can't get this kind of training and this kind of in-depth expertise around networking and especially cellular routers from anywhere else in the world right now. The first presentation was actually from the CEO remotely, from the CEO from Peplink, which was pretty impressive. don't forget about the food. One of the most important things to me is the food at a conference. And being raised in the South, this being in Savannah, it had a very Southern touch to it, which I really appreciated. Giant biscuits mixed with sausage gravy and shrimp and grits in the morning. I mean, come on. How do you beat that? I mean, some of these bigger conferences, take a note from this. This was some of the equipment that was actually running the conference. You have these antennas there on the left, those dome antennas, as well as the actual routers and switches that were making. In other words, we were in a hotel, but we brought our own technology and connectivity and enabled, very robust network bandwidth to everyone who was in attendance there. So it was unbreakable from my understanding. There was even some special equipment there. Now, not only did they have their regular, Peplink routers and stuff, they had something called the Super Station, which is something you can't even find if you do a Google search on. That is a machine you'll have to talk to Peplink about, but it has something to do with setting up these SIM cards for multiple stations, like 248 at a time, something like that. So it's pretty crazy stuff that was being talked about. This particular presentation I enjoyed about how to set up Starlink along with a Peplink cellular router and bond the connections together and make those work. It's very interesting to hear the perspective from the networking community who considers Starlink not this wild, crazy technology that's going to, it is going to change the world for everybody, especially people who can't get that kind of connectivity today, but it's just basically seen as LTE from the sky. It's not necessarily any more reliable than cellular connectivity on towers that are, a few miles down the road. It's now thought of as an additional benefit and an additional option to be added to bonding multiple connections. Starlink, just another thing to add to your Verizon, your AT&T, and etc. So that was an interesting perspective. We also heard a presentation about how to put these devices and help allow people to remotely run autonomous vehicles or even ships. There was a presentation there about running an autonomous ship across the same route that Columbus took to America. There was like an anniversary special on that, and the person who talked about that was Martin Langmaid. So I actually did an interview with him at the conference. So I want to share this interview and also an intro to the conference itself. Everybody, this is Scott Moore, and I am here at the Peplink Tech Summit here in Savannah, Georgia, and I'm with Martin Langmaid of Venn Telecom. Thanks for being on the show.
Pleasure, Scott. Pleasure.
Tell me a little bit about you, your company, and what kind of solutions you're currently providing in the network space.
Sure. So I'm from Venn Telecom. I'm the CTO there. And Venn Telecom focuses on delivering super reliable, low latency, high bandwidth connectivity all the way around the world. We're one of the first Starlink authorized resellers, and we take Starlink and 5G and 4G, we combine those to deliver really high quality connectivity wherever it's needed.
My shows and my podcast really focus on the performance and resiliency of applications, network, hardware. But we've seen, especially with things like Starlink, we've seen the network become more emphasized now in a different way, I guess. It's more important to get, faster video, higher bandwidth anywhere you are at, and that's something that you provide solutions around, right?
Yeah, absolutely. I mean, Starlink's quite interesting because, as you say, when it was first kind of released to the public, it was super fast wherever it was deployed. And over time, the capacity, there's been capacity issues and degradation of speeds in certain regions, not all regions by any means. And from our perspective, we really treat Starlink like LTE from space, right? It's like 4G from space or 5G from space. We treat it in exactly the same way, where we expect it actually to be unreliable, or we are prepared for it to be unreliable. So what we do is we combine 5G and Starlink together, and then if one of those services is unreliable, the other one fills in and covers it. And it also means that we can combine bandwidth from 5G upload, for example, with Starlink upload, and improve the capacity, the bandwidth that's available for lots of different types of services.
Are you getting more calls nowadays, especially post-COVID, for these type of solutions that we haven't had before, combining 5G and Starlink, for example, to get better performance and better reliability where we haven't been able to get that before? I mean, is that more important than ever?
Oh, yeah, for sure. I mean, COVID enforced everybody to find new ways to work, right? People had to work from remote locations, from home, and whole business services had to transform overnight to work in remote situations. And in those kind of, if you look at the different companies and applications that are out there, anything involving video, anything involving real-time video, has needed to find a way to survive post-COVID. And the only way to do high-quality, low-latency video well is with bonding, in my opinion. Combining lots of different types of internet connectivity together to give you as lowest latency as possible, super reliability, and as much bandwidth as you can, and wherever you're streaming from. And we've done a number of things, whether it be broadcast video for TV shows and for connecting remote talent to production studios, or perhaps my favorite, which is telemedicine, where we have remote hospitals. At the moment we're working with hospitals in India, for example, and we've got surgeons in France or in America that are providing consultative services over very low latency video. And that is only possible when you combine services and technologies. You can't deliver a mission critical connection without combining lots of different underlying carriers.
That's interesting. I was very impressed with your presentation here at the conference today, and there were a couple of projects. You talked about autonomous vehicles and the connectivity there. You also talked about this project called the Mayflower, which I'll put links up on our show. But can you talk a little bit about that, about how you were able to get these mini cameras on an autonomous ship and be able to monitor it from space?
Sure, yeah. So the Mayflower was a fantastic project. It was IBM sponsored, and it was this it's completely uncrewed vessel that was looking to cross the Atlantic. And of key importance was getting video streams off of the Mayflower back to the ground crews and the shore crews. And this was partly so they could monitor the progression of the vessel, of course, but it was also because to get insured and to pass the certificate authority standards, they needed to have low latency, high quality video available throughout the journey so that they could have an onboard lookout, if you like, virtual, remote, to make sure that that nothing was going to go wrong. The real challenge there was how many video streams we needed to get off of the vessel to have a full 360 view, and then how we were going to do that over very low bandwidth. In the middle of the ocean, we were working on Iridium Certus, which had 200 kilobits of upload, and we had on board, I think it was 10 cameras, IP cameras, and what we wanted to be able to do was to stream all those 10 IP cameras at the same time to get situational overview of what was happening, what was going on, in any point in time. But then if there was something very specific that was happening or an area of focus, we want to be able to dial into one of those cameras and make it go high res, high frame rate to see in detail what was happening, and that was a real technical challenge.
When you had the 10 cameras running, what was the lowest amount of bandwidth that you used for all of them together to still make them functional?
Yeah, so with 10 cameras running, I think the lowest I saw was 13 kilobits.
That's pretty amazing, actually, that you're able to do that. And it was also a software thing, right? You mentioned VideoSoft was involved in that. Was that a compression technique or?
Yeah, so I was responsible for the connectivity element, and then I needed to find a video encoding a company to help me do the low bandwidth side of things. And I reached out to VideoSoft. They're a fantastic company. They focus on low bandwidth video encoding, and they have a really interesting approach to that, which is remote controlled encoders, right? So the encoder sits on the vessel itself. It records in full frame rate, full resolution, the video streams from all of the cameras locally onto its own disk, and then you remotely request the frame rate and the resolution that you want to see over the connectivity you have, and then it does adaptive encoding based on bandwidth availability. The end result is really, really low bandwidth, really usable video, and then when you need it to be super high resolution, super high frame rate, you remotely tell the encoder to do that. So you're only consuming that bandwidth when you need it, right? And then you can dial it back down again. Very clever tech.
It is amazing, and it shows how far that we've come and how much more control that we can have these days. So it's pretty exciting where we're going in the networking world. You want to share any other thoughts about like where you see us going in the next couple of years? Like how far can we take this? Because this was a specialized solution that you provided, but I could see this being used in other areas as well. But how far do you think we can push this in the next couple of years?
Yeah, so it's a really good question, isn't it? Starlink has disrupted the world of remote bandwidth, right? You can now, if you can see the sky, you can pretty much put a dish down and get a good amount of bandwidth nearly anywhere on Earth. And as they increase their coverage, that's only going to get better. But at the same time, you've got existing technologies that are racing to keep up, right? The 5G deployments, even 4G deployments in different countries. So, in my view, I think we'll always be looking at combining multiple types of technologies and communication capabilities together if we want super reliability and super high bandwidth. One service alone won't do it.
It's got to be together.
Yeah. And then when we got that, it's the applications that then become really interesting. A bit like the Mayflower, we're streaming live video from a ship that's sailing itself across the Atlantic. What new applications can we discover because we've got the ability to reliably connect to high bandwidth? And the promise of IoT and sensors and video streaming to monitor remote situations has been there for a long time, but it's now becoming a reality because the technology is catching up.
Very cool. Thank you so much for being on the show today.
Pleasure. Thank you.
Martin Langmaid, very interesting guy. I'm actually going to share the link on smcjournal.com for this episode and the YouTube video for his page, which actually has some really good blog articles out there about 4G, 5G, Starlink, and other technologies that make great networking happen. Last but not least was the host of the conference, Peter West. And he was very busy during this whole time, but I was able to grab him aside for just a few minutes, talk about the conference and some of the things that I wanted to know about, things that I had learned, and I'm sure you'll enjoy this too. Here's Peter. Hey everybody, this is Scott Moore for the SMC Journal podcast, and I'm covering the Peplink Tech Summit put on by West Network. This is Peter West. Hello. How are you doing?
I'm doing well, Scott. How are you?
Welcome back to the show. So this is the second day. Has this conference been what you thought it was going to be? Tell me about what your thoughts are so far.
You know, it's funny because obviously we were just talking about that, and it is not really what I thought it would be. I was expecting this I was kind of expecting a different attitude of the people, like almost like a training. Like when you go to these training seminars, it's kind of boring, and I feel like that's not happening. We're getting good feedback from the people. The sessions are going really well, and so I'm kind of having a lot of fun with the fact that we're getting engagement. And
there's interactivity.
There's not a lot of that normally. Normally it's like you do a presentation, it's like A and B and C and D, and everybody goes, oh, thank you for that information, have a nice day. And we're getting a lot of interaction from the community and learning a lot. I'm learning.
I was going to say, you've learned at least 2 things that I know of today.
I've learned several things today that I never knew about Peplink, and that's the whole purpose of this community.
Yeah.
Is people, I don't know everything, you don't know everything, but the community together can share that, and that's really what we're trying to build here.
Well, I'm learning a lot about what you can do with these devices, and of course I have my own Peplink device that I go around with on the road when I go mobile. Thanks to you, you've fixed me up. Looking for that upgrade soon, I promise. But there's a couple of technologies that I was not aware of that I want to just ask you about. One of them is this eSIM cards.
So a SIM card is basically a certificate on a physical medium, like your credit card.
Right.
Okay. So a SIM card is no different than that little gold certificate that uniquely identifies your credit card when you stick in the machine. An eSIM, not the card, an eSIM is a digital certificate.
Okay.
So a physical SIM is just a certificate embedded in a circuit. And you're saying, hey, this is who I am. And so when you have a SIM card, all you're doing is saying, this is who I am. And that's it. That's all a SIM card does. And then the carrier says, oh, good, I'm glad this is you. An eSIM is a digital certificate. It's a digital code that gets loaded onto a device.
And so what that means is I can take a physical piece, put it into this device, and it can become whatever carrier I want.
There's no physical piece.
There's no physical, okay.
It's all digital.
It's all within the unit itself.
All built into the Peplink. That's what's nice.
I'm learning, okay.
So iPhone 14. Are you an Apple guy?
Yes.
Okay, iPhone 14, no SIM card slot. You cannot open an iPhone 14. It's all eSIM. There's a digital platform where you can say, Verizon, I want a SIM card, or AT&T, I want a SIM card. And then they just digitally transmit a SIM card to the device.
So where this gets interesting is if you're on the road and you're mobile, you need mobility, you might not know what network is the best choice for bandwidth in that particular area. So with this, you could switch as you needed to if you wanted to?
Yeah, you could. And so it's very similar to switching physical SIM cards. You just switch them digitally. So you could load a digital Verizon and a digital T-Mobile and then switch them.
So if it was critical where you got into an area where all of a sudden T-Mobile isn't the strongest and you needed to switch over to AT&T, or you've got two and you need dual AT&T just for an hour until you got to the next, I mean, you could literally do that.
In theory, you could. You would have to activate that SIM card and get it registered with. It's no different than registering an account. So it's not going to make it simpler, but technically make it quicker though. Because you don't need the physical card, so if they have to mail you a card or go to a store, you don't need to do that. You can just go on your AT&T.com account and say, issue eSIM, and then they give you a QR code or a code, you put that in, and then you load it onto your router.
And the use case I'm thinking about is trying to find the cheapest alternative at the time as well. So could you be dynamically switching between networks as you needed to save on costs, like you can with the cloud, where you auto scale up and you auto scale down?
The problem I would see that would be the administrative overhead associated to it.
I see.
So in theory, yes. If you had someone like Dan that had an API into the platform, he probably could write some code that spins it up and spins it down and things like that. For an end user, it would not be that easy because you have to issue the card. So it's not like you can request the card. You have to issue the card.
I see. Okay.
Now, that there is a thing where Peplink is trying to digitally provide you SIM cards using their new SpeedFusion Connect 5G. And that does help in those scenarios where I just need Verizon, no contract, for just a few seconds or a few hours. I can just issue a Verizon SIM card, use the SIM card, and then discard it.
Awesome.
Okay,
great. All right, so second thing I want to talk about is you've talked about layer 2 tunneling, all right? And that is a physical connection to a device, but then once you get that physical connection, you're sort of able to bypass some of the higher levels, and we're talking about the OSI layer, we're talking about layers here. You're able to bypass some of the higher layers of security. Can you just speak to that a little bit about what you're doing and how you're getting stuff done when you can't get it done any other way with this?
Yeah, definitely. So basically, layer 2 is the almost like the other than the physical layer.
Yeah. It's just not the cable; it's the next layer.
It's the data layer, right?
Yeah.
And so what you're saying is, I don't care about routing, I don't care about protocols, I don't care about default gateways and DNS. I'm saying, hey, here's an IP address. And a lot of this is IoT applications or legacy applications. You see this a lot in the industrial environment where they have some, controller,
temperature gauge.
Yeah, temperature gauge, or like in broadcast, like Dante, or these like layer 2 platforms. And they go, well, I'm sitting in my remote studio, or I'm trying to access this layer 2 device. And so with layer 2 tunneling, I can extend that layer 2 network over SpeedFusion to another Peplink router. So that way, it's like you were sitting physically connected to the exact same switch.
Got it. But are you turning that port on that switch into just roughly a standalone IP address that's available to anybody?
No, it's Peplink to Peplink, and I'm extending the LAN, not the port.
Got it. Okay.
Yeah. So I'm extending the LAN. Basically, they call it a broadcast domain. I'm saying this layer 2 broadcast domain that's at this facility is now being broadcast digitally over SpeedFusion to the Peplink router on the other side, so that I can access that without routing protocols. So you're bypassing routing protocols.
And I know there's some amazing use cases that you've done and that other people are thinking about. Probably they're already watching this. And yes, it's pretty cool what you can do with that. Okay, third thing. I just learned today that you now have the ability to put containers and virtual machines on a router if you've got the storage, and you basically assign, like you would if you had a VMware server, and say, hey, I'm going to give you this number of CPUs, this much memory, run an operating system or run a container on this router switch hardware. Is that right?
That is correct. Yeah, it's starting a little while ago, but really kind of getting its momentum right now. Peplink, all of our basically higher performance routers, like the 2500 EC, the EPX, the SDX Pro, the MBX, all have the ability to run KVM virtualization. It's a Linux kernel-based virtualization that allows you to spin up virtual machines. So we today, for the very first time ever, deployed a Windows Server 2022 on an EPX.
Pretty amazing. It's pretty amazing.
Yeah, and so like literally, you can think like firewall applications, readers, data collectors, things that like a lot of times you need like a Linux data collector to poll your network. Well, now you can have this polling device virtualized without any infrastructure necessary.
I'm just thinking of small cases where you just need this little container thing, or maybe you need to fire up this small little web server, but you don't want to have to buy more infrastructure or get another VM somewhere else in a data center.
So what's neat about web servers and little tiny container-based stuff are smaller routers have Docker support. So instead of spinning up an entire virtual machine, if you have a Docker app like a web server, like an Apache web server Docker app, or some other web server Docker app, or whatever application you want, you can actually load that on our smaller machines and then have these little tiny Go kit or this quick deployment of a virtual platform app right inside all of our smaller routers and our bigger routers.
That's pretty cool. And the performance of this is just basically limited to how much resources that you want to give this container or this virtual machine, right?
And on top of that, the limitations of that smaller router.
Right.
So the smaller router is going to have less resources, the more powerful router is going to have more resources.
Right.
And so just taking that into consideration for tuning and performance, right?
Yeah.
What are my available resources, and how's that going to affect my other needs of the router?
Well, I've been really impressed with these features, and there's other ones that we just don't have time to get into, but I'm learning so much about this that we are taking networking to a whole nother dimension, and the community here for the Peplink community of people here is small enough that there's frequent changes, frequent updates. You were talking about how far they've come in just 1 year and the number of changes where they're changing the firmware and different things. If you want to talk a little bit about that, that'd be great, but I was very impressed with how fast things move.
I as well as myself. It was funny because it wasn't until putting together this presentation and this course that I realized how much Peplink has done, and even so much so that we went to do a demo of virtual networking or firewalls and noticed that Peplink added another feature. They added content blocking as a centralized management. Not that content blocking matters to the channel, but that it's like as the community requests these features, whether it's a performance improvements or ways to accomplish their mission, Peplink is constantly making those changes and adapting to the community needs. And I find that to be incredibly I don't even know the right word for it, but incredibly amazing of Peplink to do that.
All these new features. We were talking about WAN analysis. So instead of just doing some speed test, to actually have an integrated speed test inside of the device, where you're actually connecting to the server or the endpoint that you really need to be concerned with, other than just some server out there on the internet. I mean, that's amazing stuff. So
It truly is. And once again, going back to performance tuning, it's my server, my destination. The problem with like a speedtest.net is it's some random server with some unknown capacity.
Right.
When I'm going to my environment, I know that from point A to point B, I have this level of capacity or latency or packet loss or whatever it might be. And so it's a more controlled capacity or testing mechanism, which when you're talking about analytics and so especially the work you do, you get that detail that you need to understand the workflow.
you have to be able to trust the data,
Yeah.
and this gives you better quality data. So, well, thanks so much. I'm having a ball, and thanks for
you.
having me here. We're at the West Network's Peplink Tech Summit, Savannah, Georgia, for 2022. Very good stuff. If you weren't here, you missed out. The Peplink Tech Summit was a great event. My understanding is they're already preparing for next year's event. Same location in Savannah, same hotel, everything, and people are already signing up. I'm actually looking forward to being there, even though it was a smaller conference. That was very enjoyable to get to meet everybody and associate people with the various companies that they work for, and get to know them a little bit better than you would a conference where there's hundreds or thousands of people there. So a little more intimate setting, but really enjoyed it. That was the very first one of those for the US. So they're going to have it again next November. So if you didn't make it to this one, make sure that you prepare for the next one, and you can go ahead and actually sign up if you want to, and we'll have links to that on the page as well. And you can reach me at my website, scottmoore.consulting. There's a link for Twitter and LinkedIn, and you can also email me at help@scottmoore.consulting. We're now towards the end of the year of 2022. Should I continue doing this podcast? Am I putting the right type of content out? Is it the right length? What would you like for me to feature on this show? Are there people that should be interviewed on this show who haven't been? That's the kind of things that help me figure out what should I be spending my time on. So please get back with us. Just like at this conference, when they were giving feedback directly to the vendor, they were helping the vendor figure out where they wanted to take the product line and the firmware, and writing firmware changes into that at a very rapid pace. We can make very quick changes to this podcast and start putting different types of content that we might not have thought about before based upon what you tell me. If you like this kind of content, it really help me out a lot if you would subscribe to our YouTube channel so you can find out when new episodes are coming out, and you can see when that is. So like, subscribe, and share with other people about this content as well. That helps me quite a bit. So thank you so much for watching. We really appreciate you, and we'll see you on the next episode of the SMC Journal. This is Scott Moore saying thanks again for watching, and bye-bye.